All right, welcome. Thank you for taking the time of joining us today. My name is Joseph Izorek. I'm a product manager at AWS, and today what we're going to be talking about is Amazon DocumentDB with MongoDB compatibility. So if we take a step back and we kind of work backwards from our customers before we get into DocumentDB, seldom do we see that one database or one data model can really fit the needs of multiple distinct use cases, that really fit all the use cases that our customers have at scale. The days of really a one-size-fits-all monolithic database are behind us, and now what we see developers doing is really taking highly distributed applications, breaking those applications down into small parts, and then using a multitude of purpose-built databases for each of those particular use cases. So instead of having the tech drive every use case, the use case is now, customers are now working backwards from the use case to choose the right tool, the right database for the job. So if you look across, broadly across all the databases that are out there, there's a number of common data categories and use cases that emerge, whether it be relational or key value or document, graph, time series, ledger, and so on. And I think what we see is that customers are using each of these in a unique and particular way to match the use case that they have with each one of these particular technologies, right? And if you look at our database portfolio, I think you can see our strategy is pretty straightforward. It's to ensure that you as developers always have the very best purpose-built technology for each of these categories, so you never have to be able to sacrifice on performance, functionality, or scale. So today what we're going to talk about is Amazon DocumentDB, a fully managed MongoDB compatible database service designed from the ground up to be fast, scalable, and highly available. So what's on the plan? Well, we're going to take a short detour. We're going to talk about what is a document database. I know that many of you use document databases today, but for those who don't, we'll talk a little bit about how we got here today. We're going to spend some time introducing Amazon DocumentDB. We'll talk about the challenges that we're working backwards that our customers have expressed to us, and talk about the unique capabilities of Amazon DocumentDB that fit those customer pain points. We're going to do 3 demos throughout the presentation to keep things interesting. So we'll do a demo of getting started in querying a document database. We'll do a live migration with DMS. We'll also do my favorite demo, taking a backup. Doesn't sound exciting, but it's probably my most favorite feature and capability. So we're definitely going to do that today. All right, so what is a document database? So, if we kind of look at those broad categories of databases and we kind of, go back in time and look forward to how we got here today, in the 70s and 80s, there's really about relational technologies. As we got into the 90s, that continued with MySQL and Postgres. And that's just the way we thought about data. No matter what our use case was, we matched it to a particular relational technology that we had already chosen. And that's just the way life was. However, if you kind of look around, the mid-2000s to present day, you see a significant increase in the number of different databases or categories of databases that are now available to you and that are widely used. And I don't think this is a coincidence that these new database models emerged at the same time the cloud was emerging, and we started to see customers build new and different types of applications that had global scale, millions of requests per second, global footprints, and different use cases and scenarios than we saw in the 70s, 80s, and 90s. Right? So if we look at what is the evolution of the document database, and there's many reasons for this, but we see we saw just a broad pattern. You look back in the database history, and what JSON became the de facto interchange or data format for exchanging data and with usage of data within an application, and that became very useful and that became broadly accepted. And then there's this problem. We had some friction, right? We tried to take that JSON document and store it to what we knew or what we were using, which was a relational database, and that created some impedance, some modeling challenges. So ORMs, or object relational mappers, came along. They tried to help this, but they created their own friction, created a little bit of friction with some performance and functionality issues. And they really weren't that, in some cases they were helpful, but they really didn't solve the problem. What ended up solving the problem was, hey, if we can just store the data and query the data in the database like we use in the application, that makes our life a lot easier. And thus, a bunch of document databases evolved to solve this particular problem. So we look at, fundamentally, really what is a document database? What are its unique characteristics? First and foremost, documents are stored like JSON-like documents in the database. Really, the JSON document is really a first-class object of the database. It's not a data type or a value. It's, the key design point of the database. The documents themselves have flexible schemas, which makes it, very powerful for representing hierarchical and semi-structured data in a very intuitive way. This actually maps a lot more naturally to how we think about documents and using data. We're able to index on that semi-structured data in those documents, which provides very powerful capabilities for a lot faster queries. And of course, expressive query language is built to query documents, either ad hoc queries or across one document or multiple documents, or doing aggregations across multiple documents. Right? And if we look back and say, okay, well, great, those are the capabilities, but what do developers say about this? Why though? And I think if you work backwards some developers and you listen to what they have to say, what you'll hear them say is, document databases really help us build applications faster and iterate quickly, which is a valuable thing. Which is valuable to developers, and if you're building out a company, because that means you're going to ship more features to your customers and spend less time in development, get feedback faster, and move your business along faster. So there's a lot of use cases for document databases. If you think about the content management, for example, right, and you think about documents as just kind of just a model or way of representing data. Think about news articles and blogs and recipes and patient records, all lend themselves really well to a document model, as that data is naturally can be represented as a document versus, say rows and columns or something that might not fit more intuitively to, the way that we naturally think about this content. We see a bunch of customers, using document databases for catalogs, right? Being able to record the output from a machine learning experiment or inventory descriptions or output from pharmaceutical trial runs, or mapping, content or metadata to objects in S3, right? We see a broad set of customers using, the flexible, intuitive nature of documents to be able to, model or capture and query that type of content. Right? Even if we look at user profiles, for instance, right? So imagine, we're building a gaming company, and your user profile when somebody signs up is probably quite simple. Right? You have an ID and a username and a first and last name. But we want to be able to evolve, as our users play different games on our platform, they do different things on our platform, they sign up for promotions. We want to be able to evolve that content in a very fluid and seamless way. And that's where documents really become very powerful means of doing that, especially within development, is they really help us iterate on that data model with a low friction, not having to think about complex schemas and normalizing data. We can just say, hey, if we played this new game called Exploding Snails, hey, we can just put that information about Susan directly into our document. We can put some other, interesting information in there, and it's all self-contained. Similarly, if Susan participates in some promotions, we can keep them in there as well, and it becomes a much quicker way to model data related to a specific person than building out other types of solutions. But there's some challenges. Working backwards from our customers, the feedback that we've gotten is, hey, it's hard to set up. It's really hard to set up a production cluster that's tuned to the way that that we need it to be. We're not database experts. We're not hosting experts. Document databases, are hard to manage at scale. Sure, we can kind of get going, but when we need to do more complex things like patching and OS updates and new versions, that becomes challenging for us, especially scaling additional replicas or increasing hardware sizes. That becomes really hard for us. Security is always a challenge to get right, to make sure we do that right all the time. And even something, we have a lot of customers come to us and say, hey, it's really hard to back up my database. I'm spending time writing my own custom scripts. It takes a lot of resources away from my database. I can only back up once a day or once a week. So my recovery point objective isn't what we want it to be, and we have to schedule this way ahead of time so we don't impact production. Can you just make this as easy as just pushing a button for us? We really just don't want to have to think about backups anymore. Can you make that easier? So working backwards from our customers, we built Amazon DocumentDB, which is a fast, scalable, and fully managed MongoDB compatible database service. And I think there's a couple. If you look at those challenges and you work backwards from those challenges, and we think about those a little bit, what did customers really want? Well, one is they really wanted a fully managed service, and there's really no compression algorithm for experience for running those services. And the second point is that the architectures that some of these applications were built on weren't really built for the cloud. They were built on monolithic architectures with attached disks, and those are really built for a client server era. And the challenge with those architectures is they scale monolithically and they fail monolithically, and that becomes challenging. When you're trying to build highly available, performant, and scalable applications. And it doesn't really allow you to leverage some of the design characteristics or some of the design advantages of the cloud. So if we kind of go back through some of these scenarios that customers were struggling with, one of them was, hey, my marketing department wants to run a promotion on Wednesday. It's Monday. They told us that we're going to get a whole bunch of new traffic. I need to scale up my database, read capacity really quickly. But to do that, to add a fourth node to be able to handle that load, I need to provision that ahead of time. And then depending on the size of my data, I have to sync that entire disk before that node can become active and participate in my database. And that replication can take a really long time. Customers told us that can take either days or weeks of time. So being able to react to their business is measured in calendar weeks versus like, hey, I can just go do this right now, and within 10 minutes I can spin this up. The second challenge we see for customers is saying, hey, during the business hours, I'd really love for my analysts to be able to run their BI queries on a larger instance. They can party on the larger instance, and at the end of the day we can tear that down so we don't have to pay for it, but then their queries are faster and it doesn't affect our production workload. Again, the challenge there is depending on the size of your data, that can take these days or weeks to add to your cluster, and that you lose the agility in that scenario. Failures are very similar to scaling, right? We add nodes that have failed the same way that we add nodes when they fail. So imagine we have a 3-node cluster and one node goes down, and we want to spin up that third prime again so that we get back to 100% capacity for our cluster. Again, that's going to take time to replicate the data from our existing nodes, and that's going to put a strain on the resources that are being used on those nodes as well, because instead of serving customer workload, they're going to be used to be replicating data over to that third node. So that's something we have to think about ahead of time and over provision for. So if kind of taking a step back at AWS, and if we look kind of collectively, building distributed services for many years and multiple database services, we really look at and say, hey, given these challenges for our customers, what could we do to improve these scenarios or improve the scalability and availability for Amazon DocumentDB? Well, there's 3 things that we would do. One, we would decouple storage and compute. And we would do that. The reason we would do that is we can offload a lot of the functionality that typically is done at the compute layer down to the storage layer. And then we can take advantages of the scale of the cloud as well. And we'll get into that a little bit. The second, what we would do is break the data into smaller partitions to reduce the mean time to recovery. And third is we'd increase replication to provide a very highly durable and available database service. So when you kind of look at a typical database architecture, you have some type of API parsing, a query processor, caching, logging, and storage. And what we did with Amazon DocumentDB is we split those two apart to decouple the storage and compute. What that really did is it really moved a lot of the log processing, durability, replication to a multi-tenant, fault-tolerant, self-healing storage layer that really offloads the database or the compute layer from doing a lot of that work, which frees it up to do more work for your customers. It also enables each of these layers to scale independently of each other, which provides a lot of advantages operationally, and also allows us to innovate on each layer independently as well. The second thing we did is instead of taking kind of these monolithic storage volumes, what we did is we broke it into smaller partitions, into 10 gigabyte partitions, and we distributed that data in a multi-AZ distributed storage volume to really reduce the blast radius of any one particular failure, and again, to help us recover faster from database failures. We'll talk about that in a little bit. And we also replicated your data 6 ways across 3 AZs. So before, one chunk of data would get now replicated across 6 ways across 3 different AZs. And that enables us to provide a tremendous amount of resiliency and durability within the service. So the architecture looks like this. For each cluster, you have a primary instance that handles reads and writes, and then additional replica instances that handle both read scale and high availability. And then all those consume from a distributed storage volume that is separated from the compute of your cluster. So let's go back to those scenarios that we talked about a little bit earlier. So let's say marketing comes on Monday and says we want to do a promotion, and you say it's Tuesday and we need to do this by Wednesday. What can we do here? How does this architecture make things easier for us? With Amazon DocumentDB, because of the separation of storage and compute, adding a new instance to a cluster is as simple as spinning up a new EC2 instance, laying our bits down, and then having that instance become a consumer of the distributed storage volume. Because the storage is decoupled from the compute, we don't have to do that expensive sync from the existing nodes in the cluster for that instance to become operational, so we can add new instances in minutes, regardless of how large our data set size is. Second, from failure recovery, right? Let's say an instance goes down. We can, same thing with scaling, is with failure recovery, we'll automatically detect that failure and be able to spin up a new instance to get you back to 100% capacity in minutes. And again, irregardless of the data size. And if we talk about failures, why do we replicate data 6 ways across 3 AZs? Well, it's to provide a tremendous amount of redundancy in the storage layer. So, things, if you hear Warner and you listen to Warner's talks, things always fail. So we have to plan for scenarios in which they do fail. So what this enables us to do is say, imagine we lose an entire AZ for our cluster. That still enables us to be able to read and write from a database cluster. Traditional database architectures, that would provide a challenge. Now let's increase the stakes a little bit and say, hey, not only did we lose an AZ, but we also lost a machine that holds another replica of our data. And this would allow us in this architecture to still be able to read from our database. Because the data is stored in 10 gigabyte partitions, if you have a 10 gigabyte link, recovering or the mean time objective only takes seconds, right? So we really reduce not only making extreme failure scenarios, be able to account for those, but also being able to say, hey, if that actually does happen, we can recover very quickly. So what we say is that provides us with the ability to handle AZ+1 failures, which provides a tremendous amount of resiliency and durability and availability within the data storage layer that's really unmatched. So we talked a little bit. Let's jump into the console and do a little tour around and quickly demo how to get started with Amazon DocumentDB. All right, so we're in the AWS Management Console. We can go down here and we can type Amazon DocumentDB. And we'll pull up the console. So to create a cluster, we'll click Create over here. And we'll give it a unique name. And then we can choose the instance class for this cluster, right? We can go up to an instance that says 488 gigabits, or we can stay with a DB4 large. Stick with the smaller instance for now. We can go anywhere from 16 instances to 1. I'll choose 1 for the purposes of the demo. We'll enter in our username and password. And we can create the cluster off to the races. We can also look at the advanced settings here. And there's a couple of things I want to point out. One is that we deploy the cluster within your VPC, right? So I'm going to choose the default VPC for this region for me. And we also select the default security group for that cluster. Now, a couple of tips here when you're connecting to your cluster. your client must be in the same VPC as your cluster. So that's an important thing to always remember. And then if you think about what a security group is, right, you can think about that as a firewall. It's effectively a firewall for both your client and your database. So when you're spinning up a new cluster, you want to make sure that, in this scenario, from our VPC, we want to be able to accept inbound connections on port 27017. Otherwise, the firewall is going to block that. So always check that within your VPC security groups. By default, encryption is enabled. You can either use the service managed keys or you can create your own keys. And again, backup is enabled by default. We can go anywhere from a backup window of 1 day to 35 days. And what that means to you is, hey, I can do a point in time restore up to the length of that backup window. Every database has 1 day configured by default, and then we can create our cluster. So I've already created a cluster ahead of time to save us a little time today. So we'll just go ahead and click on this guy. Once this is provisioned, we provide the connection string within the console, so we can go ahead and grab that. And I'm going to go over to an EC2 instance I've already set up, and I've already installed the Mongo shell. And we can go ahead and paste that in there. Right, and I can insert my password, and now I'm connected to my Amazon DocumentDB cluster. And I can go ahead and I can insert some data, and we can query that as well. Right. And then we can do a query for that data. Right, and there it is. So in a couple of minutes, we can provision a cluster and then query it with the Mongo shell. All right, so a few more coming to the capabilities of Amazon DocumentDB. We built it to be fast. We can scale out to millions of requests per second with millisecond latency. We did a bunch of work in separating storage and compute so that we really offload that compute layer for you. We had a lot more of the database replication and storage and log processing at the storage layer, which frees up that work for you. We also did a bunch of innovation we're not going to talk about today. We'll talk about at another time, of really optimizing the database engine to be only shipping logs across to the storage layer versus entire page syncs. That's advantageous for you, as it reduces the number of IOs and the number of network packets that have to go over the wire, which just makes your database faster. Right? And we also if we think about this architecture, it also makes it very flexible for you to be able to customize your cluster to your particular use case or what you want to use it for. And because durability is handled at the storage layer, this is an important point. Because durability is handled at the storage layer, you can have a one instance cluster that's still highly durable, still has data replicated 6 ways across 3 AZs, but you only have a single instance. And that's really great for getting started in dev test. Right? You can continue to add instances as time goes on, and instances help with both high availability and read scaling. Again, that takes minutes regardless of data, the size of your data. It also lets you have, different types of hybrid or asymmetric clusters where you have 2 instances that are R4 larges or 3 instances that are R4 larges, and then 1 really big instance again for scaling up for analytics workloads that you can partition off. Your analysts can run queries along against that during the day, or any combination of these scenarios. It's scalable, so we can scale up to 15 read replicas. Again, millions of requests per second. You can scale up instances. You can scale all instances up. You can scale 1 instance up. You go anywhere from R4X larges, which is 15.25 gigs of memory, up to the R4 16X larges. With storage, storage scales automatically. You don't have to think about saying, hey, I'm going to provision 100 gigs of storage today, and then I have to monitor that. When I get 75% utilization, I have to provision more. You don't have to do that with Amazon DocumentDB. Will automatically grow your storage from 10 gigs when you start up to 64 terabytes without you taking any action. It's fully managed. On-demand pay-as-you-go pricing, so you can go into the console, get started with an enterprise-grade cluster today, use it for as long as you'd like, only pay for the resources you use. We handle all the failure detection and failover for you. Point-in-time recovery, we're going to talk about backup a little bit more later in the presentation, but that's enabled by default. And of course, durable, fault-tolerant, self-healing storage service that provides durability guarantees for your data regardless of how many instances you have. We handle patching for you, of course. AWS support is there, provide operational metrics that go to CloudWatch, and also deeply integrated with AWS services such as CloudFormation and CloudTrail and DMS and VPC and a number of other services. And of course, Amazon DocumentDB is MongoDB compatible with MongoDB Community Edition 3.6. That means is you can use the same drivers and tools that you use today with Amazon DocumentDB. For many customers, it's as simple as changing an application string. DocumentDB supports replica sets, so you can still use the same client-side read preferences. And we built capabilities into DMS to make migrations from MongoDB to DocumentDB even easier for you. So let's talk a little bit about that. So DMS is the database migration service, and what that does is enables you to do either one-time or live migrations between a source and a target. So we've built capabilities into DMS to be able to provide, we already have a source for MongoDB and DMS. We provided now a target for DocumentDB, so you can migrate on-premise workloads, MongoDB workloads to DocumentDB or self-hosted on EC2. What DMS does is it tails the op log, so you can do live migrations with virtually no downtime. You can move from both either replica sets or sharded clusters. And to make this even easier for you, we've included, if you move to DocumentDB, we've included the usage of DMS to be free for you for up to 6 months. So why don't we do a live migration to DocumentDB and see how that actually works. So here's what the demo architecture looks like. So we took the Meteor to-do app, which is just the stock application on the Meteor website. We created 2 instances of that. One is a source that will go to Amazon DocumentDB, and the other is a target that is running on a self-managed replica set on EC2. So what we're going to do is we're going to use DMS to create a task to, every time we write to that target database in our application, is to replicate that data across to Amazon DocumentDB, and we should see those changes be reflected in our source application. All right, so let's go do that. All right, so here's my 2 applications. I have on the left, I have my source to-do application running on a MongoDB replica set on EC2. And here's my to-do app. And I also have my target running over here, and that's running against Amazon DocumentDB. Let's scale out a little bit. All right, so we have these 2 applications set up. So now I want to go into the AWS console, and I want to set up a DMS task to make sure that I can migrate the data between the 2 databases. So let's go back here, and we can go into the console and type DMS. And I'm going to create a new task. And that task name, I'm just going to call it Live Migration 2. And my source is going to be my MongoDB database. My target's going to be DocumentDB. And what I want to do is I want to migrate the existing data that's there and then replicate the ongoing data. So any changes that are made to my source are then propagated to my target. The schema I have, I'm going to use my Meteor application. So I'm going to add that, and then I'd go ahead and create the task. Now I've already created the task ahead of time. And so we can use that for our live migration today. It's already looking at the 2 endpoints and we're off to the races. So if we go back to our application, if I go in here and I say, hey, I want to add a new list on my source, and I want to call that groceries, right? And then I want to add some new tasks here. So we're going to get eggs and milk and oranges and apples and bananas. I don't know what else will we get. Some pop. We can go over here. We can look at our groceries, and we can see that those changes have already been replicated over. We know, I can add another list over here that says test, right? To prove we're not using the same application, because I don't have replication set up the other way. So I wouldn't expect those changes to get replicated. So what we would do there is, we eventually point our application to start writing to our DocumentDB database, let the queue drain out from our existing MongoDB database, and then we would cut the ties and we would have a live migration. So there you have it, a live migration from MongoDB to Amazon DocumentDB. All right, so moving on with some of the capabilities, Amazon DocumentDB is deployed within your VPC, right? So that gives you that strict security, network isolation, so it's not exposed to the internet. By default, encryption at rest is on. You can either use a service managed key or you can use your own customer managed key in KMS. And encryption in transit is also by default on. Either one of those you can optionally disable, but you have to go and optionally disable that for yourself, because we provide the best practices as safe defaults for you. We also got a lot of feedback that our customers wanted compliance. So out of the gate when we launched, Amazon DocumentDB has been assessed to comply with PCI, ISO, SOC 2, and is also HIPAA eligible as well. All right, backups. This is my favorite feature, and the reason why is if backups don't work, it's really hard, right? This is a really hard problem to solve, and it's something that is really undifferentiated heavy lifting. And when you need it and it's not working, it's a disaster. And it's something that, as a managed service, if you can provide this capability for your customers, you can just make their lives immensely, much simpler, much easier, and they can focus on other problems. So with Amazon DocumentDB, we really tried to make this easy. We have continuous, incremental, and automatic backups that go from a storage layer to S3. Because that is happening, the backup is actually happening from the storage layer, not your compute instances. Backups don't affect database performance, which is a huge innovation and a huge win, that you don't have to over-provision your instances to be able to account for the backups you take. Up to 35 days of point-in-time restore. So that gives you, continuous backup for a really long period of time. And you can always take a snapshot whenever you want as well. Let's say you have a scenario and say, hey, we're going to do a rollout. We just want to see, we just want to take a snapshot of our data before we do that rollout, or you want to take a snapshot and restore it so you can do some testing or some development work on it, or you want to share, that snapshot to another account in a region. You can do that at any time as well, and keep those snapshots for around as long as you need them. Right, so this is what the architecture looks like. So from that distributed storage volume, we're syncing those backups to S3, which provides a tremendous amount of durability. But again, it offloads the database from having to do that task. It gives you better performance. So let's go ahead and let's go do a demo of backup. So let's go back into Amazon DocumentDB. All right, so if we go back into the AWS console, I have a cluster that I already created. I can go in here and I can modify this cluster, right? And I can go down here and I can, my backup period is 1 day right now. I can move that to 35 days, right? Also, I can also take this cluster and I can say, hey, I want to perform a point-in-time restore, right? So I can say, hey, I fat-fingered something, I messed up my application. I want to restore to 1 hour ago. I can go ahead and restore my cluster to a new cluster and get going again. Or I can just say, hey, I just want to take a snapshot. I want to, have some peace of mind. Maybe it's the first of the month and I need to do some type of auditing and I need to keep that snapshot around for a while. I can just go in and say, hey, take demo snapshot. Like spell. All right, and I can create that snapshot and we're off to the races. So there's 3 ways of dealing with backup in Amazon DocumentDB. That's as simple as a click of the button. Thank you for your time today. For getting started, please see aws.amazon.com/DocumentDB. There's a lot of resources there on how to get started. You can either use AWS Management Console, the CLI, or CloudFormation. We've got a tremendous amount of feedback from our customers that worked with us before we launched. We're really appreciative of everything all the feedback they've given us and helped us shape the product. We're continually looking forward to your feedback as well and working backwards from the features and the things, the capabilities that you want us to build. At AWS, 90% or more of our roadmap is determined by what you want us to build. So the more feedback you can give us, the quicker we can build those features for you. We've built a tremendous amount of capabilities in the store into the service to make it fully managed and easy for you to use. We're looking again forward to your feedback and thank you for your time.